All right, so welcome everybody. It's really awesome to have you guys here with us again on Thursday afternoon. We're going to pick up right from where we left off on Tuesday. Just a quick recap, the people that are joining us today for the very first time, our course on trigonometry started a couple of weeks ago. So far, we've managed to do a bit of revision of grade 11, and then we differentiated the courses. And this course is the slightly more advanced course. We are going to be dealing with more sort of difficult sorts of questions throughout this particular trigonometry course. And what we've done so far is we've looked at compound angles and we've looked at double angles. And in the lesson sort of from today onwards, we're going to be looking at how double and compound angles actually feature in grade 12 trig. Because now that you've seen them and you've worked with them and you know what they are, you have to expect and be looking for them in the sorts of questions that we're going to be asked, or that you're going to be asked. Okay, so let's jump straight into it. I didn't finish this off the last time, and I just felt that it was important for me to show you this before we actually get into Pythagoras. You can, so this is a continuation. Example 8 is a continuation of what we were talking about with double angles last week. So they would expect us to be able to answer questions like this, where we would need to evaluate things. And again, we're not allowed to use a calculator. So more than likely, this comes down to some kind of special angle in the end. So our special angles are important as well. Okay, so when we have a look at number 1, matrix, when we look at the numerator, we can see that the angles used in the numerator are acute. So we really want to leave those as they are right now and concentrate on the angles in the denominator. All right, so we can see that both of those can be reduced. So if we can use our grade 11 reduction formulae, that's what we always do first. Okay, so tan 225, that's quadrant 3, where tan is positive. So this is going to reduce to positive tan 45, and hopefully you already know what that is equal to. And then cos 200. Okay, so cos 200 is also third quadrant, where cos theta is negative. So this has to reduce to negative cos 20. I hear you all say, no, I'm talking nonsense. Not cos 20, cos 40. Okay, so 180.
No, it should be 20.
No, sorry. Beg your pardon. It's been a long day.
That's okay.
Quite right. 180 plus 20 is 200. All right, there we go, 100%. Okay, so we know that the tan of 45 is equal to 1. No calculators, okay? You need to learn these off by heart. So what we're left with, matrix, is the sine of 35 times the cos of 35, all divided by negative cos 20. And this is where, if we do not know our rules and we do not know our co-functions, we will forever be lost. You have to go and learn the theory. Otherwise, you just cannot do it. All right. With this particular question, what they want you to do is find a connection between 35 and 20. Right? But it's not obvious. There's a couple of steps. So instead of me telling you, I want you guys to tell me, what do you think? What do you think we need to do here? How are we going to find this connection between 35 and 20? No one? So it's got something to do with double angles, and it's got something to do with co-ratios. So in other words, what I'm trying to say is never, ever, ever forget that if you have been given, for example, the cos of 20, that you can rewrite that. Okay, so you can rewrite the cos of 20 as the sine of matrix, the sine of 70. Okay, you absolutely have to know that. All right, so if you don't know these, there's no ways you guys are ever going to be able to answer these questions. All right, so this is co-ratios. So what we're going to do here is we're going to rewrite negative cos 20 as negative sine 70. Now, I don't know if the relationship between the 35 and the 70 is becoming a little bit clearer to you. What I'm going to do is I'm just going to move these things down, just give us a bit more space to write here. And now we know that 70 is double 35, isn't it? So sine 70 is a double angle, all right? So that can be written as, I'm just writing the numerator again. So sine 35 cos 35 over negative, and then hopefully this makes sense to you that I can write it as 2 sine 35 cos 35. Okay, because this is a double angle. All right, and now mathematically, I've got something times something over something times something. So now I'm allowed to cancel down. Anything divided by itself is 1. Anything divided by itself is 1. My final answer matrix, minus 1 over 2. Okay, how do you feel? You're all dead silent, and that worries me a little bit. You can put something in the chat. Happy, not happy. Okay. Yes, Njabulo. All right. Okay, thank you. Thanks for the thumbs up. Happy. Okay, thanks.
Ma'am, Jabul is asking if you could possibly explain again. I think you may have lost them somewhere.
Where did I lose you, Njabulo?
Can you unmute and maybe speak to ma'am about where she lost you?
Ma'am, like my network is giving me problems, so I didn't hear anything that you said from the start.
Okay, all right. That's fine. Then what I'll do, Njabulo, is I'll explain this one to you again. Do you understand where I got tan 45 and minus cos 20 from? So that's your normal grade 11 reduction formulae.
Yes, ma'am.
Okay, so that makes sense to you, okay? So I've got sine 35 times cos 35 over negative cos 20. Then what I had to do here is I have to try and find a relationship between 35 and 20. And of course, there isn't really one. And that's why, that's the clue, that there's a couple of steps that I need to take here, all right? So I can rewrite the cos of 20 as the sine of 70. And 70 is double 35. That's the connection. Okay, so in other words, what I'm saying is this: cos 20 can be written as sine 70, and 70 is 2 times 35. Okay, that's the connection. There's two steps in the connection here. So that's going to be my first thing. Our first task. I want to rewrite cos 20 as sine 70. So I'm going to rewrite the top, sine 35 cos 35. I'm going to rewrite the bottom, not forgetting my negative. I'm going to rewrite that as negative sine 70. And then I'm going to use my sine double angle formula. So in other words, here I'm going to write this as 2 sine 35 cos 35. Okay, that's my sine double angle identity. So I'm expanding not forgetting my negative, 2 sine 35 cos 35. And now in Jabulo, all that remains for me is to cancel down. So anything divided by itself is 1. Anything divided by itself is 1. I'm left over with 1 on the top, 2 at the bottom, and then I've just got to remember that it's negative. Okay.
Thank you, ma'am.
It's a pleasure, Jabulo, no problem. So this is the sort of thing, the sort of calculating they can expect you to do. All right, let's just have a look at another one before we go ahead and jump into some practice for you guys. In number 2, they're asking us to subtract fractions. All right, so what are the rules with regards to subtracting fractions, matrix? This goes back to grade 6, grade 7. How do we subtract fractions? What do we absolutely have to have? Aha, Kumo, lowest common denominator, quite right. So in exactly the same way that if I said to you, what is 1 over 3 plus 2 over 5? And you'd say to me, Lee, we need a lowest common denominator. I'm going to multiply 3 and 5 together. It's the same story here. Okay, we need a lowest common denominator. And we're going to have to multiply together sine 12 and cos 12 in order to get our LCD. So our LCD is sine 12 cos 12. All right. So just like this over here, where my LCD would now be 15. What I did here is I times that by 5 to get 15. So I have to do the same thing to the numerator, don't I? So same story here. At the bottom over here, I times this by cos 12 at the bottom. So I have to times the top by cos 12 as well. So I end up with sine 36 cos 12 minus. Then similarly over here, I've got to times that by 3 to get 15. So I must times that by 3 as well. So here I times that by sine 12. So I've got to multiply the top by sine 12 as well. And that's why I end up with cos 36 sine 12 as my second term in the numerator. Now, you guys in matric should be looking at the numerator and saying, yes, 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 this is a what sort of angle, matrix?
Is it a compound angle?
It is a compound angle. Lovely. Yes, Kanyusila. Yes, Cassandra. It is a compound angle. So now we need our compound angles in order to be able to reduce. Now, remember, this is the, not to reduce, in order to do the reversal of the expansion. So remember, it's like the lock and a key. It has to look exactly like one of our compound angle formulae in order for us to work backwards. Sine cos, cos sine, 36, 36, 12, 12. It certainly does. Which compound angle is this? Is it a sine or is it a cos?
It's a sine.
It's a sine. It is. Okay, and remember, sine keeps its sine. Sine keeps its sine. All right, so that means that we can write this as the sine of 36 minus 12, sine keeps its sine, over the sine of 12 times the cos of 12. So this gives us the sine of 24 over sine 12 cos 12. And what do you notice about 24 and 12, matrix? It has to be a what sort of angle?
A
Double angle. Indeed, it has to be a double angle. Okay, so just like we wrote sine 70 as 2 sine 35 cos 35, I've got to do exactly the same thing with sine 24 over here. So I'm going to rewrite sine 24 as 2 sine 12 cos 12 over sine 12 cos 12. And just like the example on the left, anything divided by itself is 1, anything divided by itself is 1, and 2 over 1 gives me a final answer of 2. So can you see compound angles and double angles came into this particular question? Okay, so these are the sorts of things they're going to expect you to be able to do without a calculator. Okay, guys, no calculators are allowed. All right, so now I've talked enough. Let me give you an opportunity to try. Yeah, thumbs up or thumbs down. How are you feeling? Lovely. Oh, I'm so glad to hear that. That's great, guys. Well done. All right, so now, this is for you to try. Again, I'll just move that down and out the way. Right, this is for you to try. If you want to do 3, you're more than welcome to do 3. I really don't mind. E and F are slightly sort of more difficult questions. What I would really like is for you to either try A and C or B and D. But it's your choice. Maybe what you want to do is do either A or B or C or D, and then we'll have a look at E and F together, because E is it's easy, but it's difficult. And then I just want to show you, I want to show you F as well. Okay, so if you want to practice finding the lowest common denominator, then definitely try B. Question A, a lot more simple. All right, okay, so you guys give that a try. You're going to do either A or B or C or D. And then put a thumbs up or a done when you finished. And of course, if you want to ask Coco and I any questions, we're right here for you. Okie dokes. There you go, Miso. Can you see everything? I'll just move this up so that people can still see it. No problem, Miso.
So do we just have to do either A, B, C, or D, or we have to do A?
You could
and
do,
B?
so what I'd like you to do, Ryle, is to try two. So either A or B and either C or D. So you're doing two questions.
Okay. Thank you.
Okay, so the choice is yours. Okay. How's it going, Matrix? Difficult. Okay, Tatsuo. Okay. All right, so Pilo says not good. Tatsuo says difficult. Njabulo, you're not 100% sure what to do next. Okay. So in Jabulo, if you've got 2 sine 75 cos 75, that's the expanded double angle formula, isn't it? Sine double angle formula. So now you need to go back and write it as a double angle. All right. So should we start talking about answers? And then how we should have done these? Are we ready to do that? Okay, Mark says yes. Okay, cool. Thanks, guys. All right, so in question A, you should have got 1/2 as your answer. In question B, your answer should have been √2/2. In question C, your answer was -1/2. And in question D, the answer was also 1/2. Anybody?
Ma'am, can you please do C for me?
Sure. All right. So I'm sure that there are a few people who would want C to be done. Now, did you make sure that you copied carefully? Because I know that the boys at my school all called me over with this question. They couldn't do it. And what they'd done is they'd written this down wrong. They'd written it as 225 instead of 255. All right. So we can see that this and this needs to be reduced. Okay, so that's going to be our first step. Let's reduce those. Okay, so this is going to be second quadrant where sign is positive. So this is going to reduce to positive sign 75. This over here, however, is quadrant number 3. So that means that it's going to be negative. All right, so 180 plus 20 would get us to 200. So this would be 75 over here. All right. So now what we've got is something that's positive multiplied by something that's negative. So overall, the sign is going to be negative. It's going to be negative 2 sine 75 cos 75. And this over here, let's use a different color for highlighting. This over here, that is your expanded sine double angle formula, isn't it? So in other words, when we do this, we want to do the reversal of the expansion. So we're going to leave the negative on the outside, and we're going to write this as 2 times the sine of 2 times 75, which is going to leave us with a sine of 150. Now we can reduce further. Okay, 150 is quadrant 3. This will reduce to negative sine 30. And remember, the sine of 30 is a half, and that's why the final answer was -1/2. Oh, you forgot the negative. It's a very common mistake in Jabulo. You know, with a lot of these things, what I find with a lot of matric students is they make little mistakes. They forget out negative signs, or they don't write something down, and then it changes the meaning of everything, and then it just all goes badly from there. Okay.
Thank you, ma'am.
It's our pleasure. Keketso is saying, ma'am, is b square root 2 plus? You could have also had 1 over square root 2 as the answer there. I can do this one quickly if you want me to as well. Keketso, can do B? I'm sure you won't be the only person wanting us to do that. Okay.
Sorry,
Yeah.
ma'am, for question C, how did you get minus cos 75?
In question C, how did you get minus?
Cos 75.
Okay, so that's your grade 11 reduction formulae, Ryle. Okay, so 225 is quadrant 3. Cos is negative in quadrant 3. So I'm using the reduction formula 180 plus 75. So that reduces to minus cos 75.
Okay, thank you.
Okay, no problem. All right, yes, let's just do B. Okay, now cos squared 25.5 plus sine squared 25.5 is equal to what? Cos squared theta plus sine squared theta is?
1.
1, exactly. Okay, so the numerator, whoopsie daisy, let's change the pen. The numerator is 1. Okay, cos squared 22.5 minus sine squared 22.5 is our cosine double angle formula. Okay, so this is going to become cos
45.
45. Does that make sense? It's a cosine double angle. And the cos of 45 is root 2 over 2. So if you take 1 and you divide it by root 2 over 2, your answer would be inverted. Okay, so if you've got, so this means 1 divided by root 2 over 2, which is 1 times 2 over root 2. And then, oh, sorry, it would be 2 root 2. No, it wouldn't. It would just be root 2. Sorry. I made a mistake here. This would be root 2 would be the answer. And then you would have to rationalize your denominator, because, or you could just leave it as, why did they say 1 over root 2? Cos 45 is root 2 over root 2 over 2. 1 divided by root 2 over 2.
Not just root 2, man.
It would be root 2, yes, because
Yeah,
now
that's
you would
what I
multiply. So the final answer would be root 2. Yeah. The back of the book must be wrong. Okay, so this is your final answer. Yeah. That would be it. It would be root 2. Okay. Can you see that? Can you explain to me where I lost you in B? Where are you lost? How did you get cos 45? Okay, so here, this is your compound angle, no, sorry, your double angle. This is your cosine double angle. Cos squared theta minus sine squared theta. Maybe what I must do, hang on a second, let me go back here.
I was about to recommend, if you don't mind.
Yeah,
Guys,
sorry, I know my formulae so off by heart, and then I always forget that, you know, obviously the matrics don't know their formulae off by heart yet. Okay.
These somewhere and
Of course.
reference back to them as we go, because they.
Okay. All right. So here you go. Can you see it from here? Okay, that's what we've got. All right. So I'm doing this with it. 2 times 22,5, and that's where the 45 came from. Does that make sense to you? Sorry, I should have put the formulae up from the beginning. Okay, all right. Are there any other questions that you guys want to ask? Anything else that you'd like me to go through? D. Okay, Cassandra, no problem. All right, so let's have a look at question D. Question D is 2 cos 15 cos 75. Okay, Pilo, you want me to do A as well? No problem, we'll do that after this. So again, this is where your co-ratios are just so important. How else can I write, and it really doesn't matter, how else could I write cos 15?
As a sine 75.
Exactly, I could write it as sine 75. Or if I wanted to, how could I write cos 75?
Sine 15.
Sine 15, absolutely. So I don't want to change both of them. I just want to change one of them. All right, so it's your choice which one you want to change. All right, so let's say we decide that we want to change cos 15. We want to do this. We want to change cos 15 to sine 75. So this cos 15 is going to become sine 75. Okay, now the reason that I want to change it to that is because it looks like this. It is a sine double angle. Okay, so if I change it, then it's going to look like that. Now it does. Now I can do that with it. All right, so 2 times 75 is going to give me 150. Indeed it is. So this is going to become the sine of 150. And the sine of 150 using your grade 11 reduction formulae is the same as the sine of 30, because it's 180 minus 30, and that's equal to 1 over 2. Okay, so that's where that one comes from. Okay, and then the last one, let's just rub this. This is number A. Let's do that one for you guys. All right, so A was sine 40 cos 40. And then at the bottom, we've got sine 100. Okay, so we can reduce sine 100. All right, so we can reduce it to sine 40. Well, we're not reducing that, we're just rewriting it, but we can reduce sine 100 as the second quadrant where sine theta is positive. So this is going to reduce to positive sine 80. 80 is double 40. Okay, so what you've got here in sine 80, this sine 80 is 2 sine 40 cos 40. Okay, can you see now here how we are going? Back the other way. It's always from the one to the other and then back again. All right, we're always switching between the two. Either they give us the right-hand side and we do the reversal of the expansion, or we've been given the left-hand side and we need to expand it. Okay, so it's this fluid movement backwards and forwards between the two all the time. All right, so now we're going to write this as sine 40 cos 40 over 2 sine 40 cos 40. All right, so this is very similar to the one that we did in the example. Anything divided by itself is 1. Anything divided by itself is 1. And our final answer over here would be 1 over 2. Okay. Was that all right, Matrix?
Thank
How
you,
do you
ma'am.
feel? Pleasure. How do you feel now? Pleasure, Pilo. Good. Okay. Yeah. No, I completely understand. Trig is not easy. And it's easy, it looks easy when you watch somebody else do it. But when you actually have to do it yourself, you realize that it really is not as straightforward as we would have hoped. Okay, so this is what I wanted us to cover this lesson. I'm going to beetle on and try and get started on this. Let's just see, there's one more. It's a pleasure. Bochepo, that's quite likely. You can, that's not the only way that you can do things. Chances are if you ended up with the same answer, what did you do, Bochepo?
Ma'am, when it came to sine 40 cos 40 over sine 100, I saw that
Yes.
sine 100 is double 50, so I said sine 50, that made it 2 sine 50 cos 50. Then I realized that sine 40 is 90 minus 50 equals to cos 50. So it's like it switched around, but it had 50 inside. So what was that fine or?
Yes, absolutely. So did you write the sine 40 at the top as cos 50 and the cos 40 at the top as sine 50, and then you would have cancelled?
Yes, ma'am.
Perfect. Perfect, perfect, perfect. Absolutely. Yeah, you see, there's so many different ways in which we can do these questions. Absolutely. And your teachers will know this. So they will be aware when they are marking your work that there is always more than one way to be able to do something. Okay, so nothing wrong with that. I'm actually really impressed, Bochepo. Well done. And thank you for explaining that so nicely as well. That was really awesome. Good job. Okay, good spot. Okay, so now it's a pleasure. Well done on doing good work. All right, so now these sorts of questions, do we remember these from grade 11, grade 12s? All right, so if tan theta equals 3 over 4 and theta is an angle between 180 and 360, calculate without the use of a calculator and with the aid of a diagram the value of sine 2 theta, cos 2 theta, tan 2 theta. All right, so this is a popular question. Often comes up in tests and exams. We call these questions that they're based on the theorem of Pythagoras, right? But before we can actually set about answering A and B and C, we've actually got a lot of work that needs to be done first, right? The first thing that we need to establish is which quadrant are we working in? All right, because we need, in order to be able to answer sine theta, cos theta, and tan theta, we need to, what we would do is we would interpret sine 2 theta as y over r, and cos 2 theta as x over r, and tan 2 theta as y over x. So that means we need to know the value of r. If they give us tan theta, we don't know the value of r. Remember, tan theta means y over x. Okay, the other thing that I want you to have a look at here, guys, is this. We are working in terms of theta, but they are asking us in terms of 2 theta. Okay, so now if we are given theta and they ask us in terms of 2 theta, it's a little bit easier. They can also do it the other way around, but I don't know if we'll get an opportunity to discuss that this lesson, but I'll certainly try, right? So the first thing we need to do is we need to work out which quadrant are we working in. And these 2 pieces of information, the one with a pink block around it, and the second one with the pink block around it, those 2 pieces of information help us narrow down which quadrant we are working in. We're going to draw ourselves a quick little cast diagram, and then we're going to tick the appropriate quadrants. Tan theta is positive. So this over here, its sign is positive. In which 2 quadrants is tan theta positive? In quadrant number 1 and quadrant number 3, I hear you all say. All right. Also, theta is an angle between 180 and 360. So it means it starts at the 3rd quadrant and it ends at the 4th quadrant. So it's either one of those 2. And here, where I've got my 2 ticks, that's where I'm drawing my terminal arm. Okay, so I am working in quadrant 3. Yes, Mark, you are quite right. Quadrant 3. So now, yeah, sure.
As far as I know, both x and y in that quadrant are negative. So how do we end up with positive?
Because a negative divided by negative is a positive.
Thank you very much. I think I already knew.
No problem. No problem. Okay, but can you see why this is so important? Because if you came along and you said that y was positive 3 and x was positive 4, you would be wrong. Okay, that's why it's so important that we work out which quadrant we are working in. All right, because then our signs would be incorrect. Okay, so here at the end of the terminal arm, it is indeed -4 and -3 that are the coordinates, grade 12s. Okay, so that is why it is so important we know which quadrant we are working in. Remember, x and y change sign depending which quadrant we are working in. R is the length of the terminal arm, aka the hypotenuse, this thing over here. It's anchored at the origin and it's swung anti-clockwise, theta degrees to come to rest in quadrant number 3. R is always positive. So now we've got to do the theorem of Pythagoras to work out the value of R. So we will say x squared plus y squared. Please, 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 when you substitute, you must substitute in brackets and put exponents on the outside. Okay, very, very, very important. Is equal to r squared. So that's going to give us 16 plus 9, which gives us 25 is equal to r squared. R is always positive because it is a distance. So therefore, r is going to be equal to 5. What I like to do with these sorts of questions is that once I've worked out either the missing x or y or r, I like to make myself a little summary because then I can work from there. So we know in this case, x is equal to -4, y is equal to -3, and r is equal to 5. Now I can answer anything that I want. Okay, so that's all the work that has to take place. Yes, Lorata, r is equal to 5. Good. So that's all the work that needs to take place before I can get started. Now only am I going to try and answer the questions. So the first question wants me to work out the value of sine 2 theta. Now, this diagram is in terms of theta, not 2 theta. So if I want to work in terms of theta, I've got to expand my double angle. So I will get a mark for writing this is equal to 2 sine theta cos theta. So we interpret that as 2 times sine theta is y over r. So -3 over 5. Cos theta is x over r. So this is minus 4 over 5. And if you pick up a calculator now to work out the answer, no one's going to really mark you down on that. It's just, you know, getting to this point here where it's really important that you didn't use a calculator. But hopefully you don't need a calculator to work this out, because a negative times a negative is a positive, and 3 times 4 is 12, and 12 times 2 is 24, and 5 times 5 is 25. Okay, does that make sense to everybody?
Yes, ma'am.
Cool. All right, let's have a look at the next one. The next one, not very exciting. They've given us cos 2 theta. All right, now it's totally up to you, Matrix. Okay, you can choose to write cos theta. In Pythagoras questions, it does not matter how you write cos 2 theta. If you want to write it as, let's just go and fetch our formulae. Sorry, I should have done that earlier. I'll remember the next time to try and include the formulae. I should have done that. I'm sorry, I didn't. Okay, so there's our double angle formulae. Now, when it comes to the theorem of Pythagoras, okay, these sorts of questions, whether we write this as cos squared a minus sine squared a, or 2 cos squared a minus 1, or 1 minus 2 sine squared a, it does not matter. Okay, later on when we do identities and equations, it will matter how we choose to write cos 2a, but for these sort of Pythagoras questions, it really doesn't matter. So pick whatever you like. All right, maybe because I don't know, should we go with 2 cos squared a minus 1? It doesn't matter. So we interpret this as 2 times, okay, now cos a, sorry, it's cos theta, not that it really matters, sorry, cos theta. So in terms of what we were working with in this particular diagram, we said that cos theta was minus 4 over 5. So this is times minus 4 over 5, and that has to be squared. Okay, so cos theta is minus 4 over 5 squared gives us cos squared theta, and now we need to take away 1. Okay, so this would be 2 times, that would be 16 over 25 minus 1. So that gives us 32 over 25 minus 25 over 25. Sorry, I'm just doing this without a calculator. And that means we would be left with 7 over 25 if I haven't made any mistakes. Does that make sense to everybody?
Yes, ma'am.
Cool, Tatsu. Thanks, Thelma. Tisha says yes. Bochepo says yes. Letu says yes. Cynthia says yes. Nice. Cool. And Injabulo as well. Lovely. Good. And Maite. And Tabile. And Zianda. Cool beans. All right. So now let's do the last one. Tan 2 theta. And Gaussiami. Lovely. All right, so tan 2 theta, we would write that as?
Sine 2 theta over
Sine
cos.
Exactly. Well done. Okay, so we would write tan 2 theta as sine 2 theta over cos 2 theta. Well done. Incidentally, I must just tell you, sorry, I didn't say this earlier, but let me just say it now. Whenever you expand one of your compound angles or double angles, you will always get a mark for that. Okay, so very important that you write what sine 2 theta is equal to, what cos 2 theta is equal to, and in this case, what tan 2 theta is equal to. You have to write that first and then sub in. Okay, you get a mark for writing it. So always, always, always make sure that you do that first. Okay, and now we don't have to recalculate anything. Okay, so if we already know what the answer of sine 2 theta is, we can just go and sub that in. We know that it's 24 over 25. And we are dividing that by cos 2 theta, and cos 2 theta was 7 over 25. So now when we work with fractions, we have to be able to, well, when we divide fractions, we've got to tip and times, right? So that means the 25 goes to the top and the 7 comes to the bottom, and anything divided by itself is 1, and therefore the final answer would be 24 over 7. Okay, matrix. There we go. Who did that? Kanyisile. Well done. Very nice, Kanyisile. Good job. All right, now we've got just, time goes by too fast. Hey, I say that every time. All right, you guys try one. Okay, it's this one over here. I don't know if we'll manage to get all the way to the very end. Also here, bear in mind, the first thing that you need to do on both sides is divide by 3. So in other words, you want to end up with cos theta equals root 5 over 3. Okay, so you take it from there, work out which quadrant you're working in, draw your diagram, calculate what's missing using Pythagoras, and then you can answer the questions. Okay, ready, steady, go. Cool, Cassandra. That was really fast. Well done. Oh, and Thelma. Okay, can you see you got A? Yes. Can you see there? That's right. It should have been, was it negative or positive? Can you see there? Cool, Tatso. Okay, so let me get started on this. It's just because I want us to, yes, can you see there? Perfect. All right, good job. Okay, so maybe I don't need to actually work everything out entirely. In part A, matrix, you should have had an answer, because I know Kanisila shared her answer with me and she's got it correct. You should have had -4 √5/9. And for B, you should have had 1/9. And for C, you should have had -4 √5. Okay, so you're all done. Is there anything that you didn't get that you would like me to do? How did that go for you guys? Perfect. Oh, Tisha, that's great. Well done. That's excellent. Good, good. Cool, Casey. Cool, Tsahofatso. Letabo, perfect. Oh, brilliant. Okay, so Zozbini, did you get your quadrants correct? Okay, so just double check on that. Look, cos theta is positive. So it's either quadrant 1 or quadrant 2, but it starts at 180 and ends at 360. So we should be working in quadrant 4, which means that when we calculate the corresponding value of y needs to be negative. Okay, so in this case here, we would have had √5 squared plus y squared equals 3 squared. So that gives us 5 plus y squared equals 9. So y squared is equal to 4, which means that y should have been -2.
-2, okay.
Yes. Okay. So then if we've got in A, if we've got sine 2 theta, we're going to write that as 2 sine theta cos theta. We must. And that becomes 2 times, and sine theta will be -2 over the value of r is 3, multiplied by cos theta, which in this case is √5/3. All right, and that's where we end up with the 2 times -2 is -4 times √5/3 times 3 is 9. That's where that comes from. Okay. Oh, Peter, I'm so happy. That's excellent. Well done. What can you see? Wonderful. Good. It's so nice to end on a positive note. Sisanda, it doesn't matter. So in these types of questions, in these types of Pythagoras questions, it does not matter which expansion for cosine you use. You'll get the same answer with all of them. Okay. So that doesn't matter. We've got to run a poll with you guys quickly before we say goodbye. So I think we better just do that now. Okay.
Can I just ask? Sorry,
Yes.
I just can I pop the link to the quiz for tonight in the chat, because
Yes,
I've got to
please.
run.
No, that's fine. Pop the link to the quiz in. Thank you.
All right, thank you so much. I will see you all next week, Tuesday. And thank you guys so much. This class is always so fun having you guys here. Okay.
Absolutely.
Bye, everyone.
Thank
I'll
you,
see
everybody. And then if we can just do the poll. Bye, Coco. I'm just going to launch the poll quickly. There we go. If you guys would just answer that, and then you're welcome to say goodbye, unless you want to ask me a question. But please go and try the quiz after this.